This week we'll continue making our NDBC API service, and we'll add API features for being able to query a certain buoy or being able to query all buoys for a certain variable. Welcome to another MetPy Monday. Hello, I'm John Lehman, a software engineer for Unidata. This week we're going to have part 2 of our Making an API series with Flask, and we're going to enhance the capabilities of our basic service that we had last week. So what we're going to do is use a GET request, which is when you see a URL that's got a question mark and then a variable name and an equals after it. That's the type of request we're going to make. There's also something called a post request that we can get into in future MetPy Mondays if there's interest. But for the GET request, it's very basic. We're just going to make a couple of different routes for our application, and then we're going to parse the user parameters out of those GET requests. So first, looking at our get data for buoy function. Overall, I'm pretty happy with this, but there's one thing I do want to change. It's still returning to us the date time in a pandas/numpy type format. And I really want it in my JSON to be a string that my user can then do whatever they want with. So to get around that, I'm going to use one of my favorite Python syntax tools, the list comprehension. So I'm going to set time to be the list comprehension of datetime string format time, a time t, and the format, which I want to be year, month, day, and then a capital T, an hour, and a minute. Seconds don't really make sense for buoy data. And we're going to do that for each time that we're going to call t in df time. So remember, this is the same as a for loop that says for t in df time, we're going to append this thing to a list. This is just a way to do it in one line. That's pretty nice. And it's really concise syntax. And of course, that means up here, we're going to need to do an import from datetime. We're going to import datetime. Okay, I'm going to go ahead and add another couple of imports up here. I'm going to import JSON. And then from Flask, I'm going to import request. We'll use all of these here in just a little bit. Okay, now we need to make a new route in our app. App.route. The route for our what we had done last week would be called a single buoy route. So this is the URL that my user would go to. And it's going to have the get method. And of course that needs to be decorating a function. And I generally call the function the same thing as the route, but I use underscores. That's just my personal convention. So this route is going to get data for a single buoy, which we had already done. But I want to make a couple of modifications here as well. So right now, it's going to do exactly what it did last week, but we need to take that user input. So the request that the user gives us is in the request.values attribute, and we're going to make sure that that's a dictionary, something that we can get into nice and easily. So here, instead of hard coding buoy 15006, from our REQ dictionary, I'm going to use the get, and then whatever I want my, it could be var name, it could be whatever you want your user to pass you. In this case, I'm going to call it buoy number. That seems to be relatively intuitive. So that will get us our buoy data. I'm going to go ahead and build in a little bit of error handling here. If buoy data is not none, then we will return the data. Otherwise, we're going to return no valid request. Okay, now we can do a little bit more improvement here as well. Right now we're just sending a string, which actually is going to work just fine, but it's a little nicer to use the JSON dump string, or JSON.dumps. This makes sure that everything is properly formatted for JSON output. Okay, so we're going to save that. What else are we missing? Well, we don't have anything in the home route now. And since the home route isn't really going to be used, it's not part of the API, I'm just going to put the string here, h1 buoy API. But again, that's not really something that you're going to use as you're programmatically querying this API that we're making. All right, so let's fire up our application. And it says we've got an error. All right, so we need parentheses there. And since this prevented it from starting, it actually didn't start the web server because it was a syntax error. Once the web server gets started, they can be a little bit trickier to find. So now we've got the MyAPI app fired up. Let's go navigate to it in our browser. All right, so the home route shows buoy API as an H1, but we are going to go to single buoy, and you see it auto-completed for me there, but it's single buoy with a question mark, and then the things that we want to pass in the request. So buoy number equals 15006. And there we have our data. Now all I've got to do is click up here and change that to say 46006, and I get data from a completely different buoy. So this request is taking this information that we're passing in the GET, it's breaking it out, doing the data retrieval, and returning the appropriate JSON to us. That's great, but let's go one step further. Let's make a get variable for all buoys method so that you could say, I just want air temperature. I'm going to make a map of air temperature. Just give me air temperatures at all the buoys. Okay, so we'll run back to our code. And in the code, you can do this either way. You can make the data handling method first, or you can make the route first. I'm going to go up here and deal with the data first. And I'm going to copy and paste this. Always a little bit dangerous, but a lot of the basics are going to be the same. So I'm going to say get variable for all buoys. And that's going to be var name. Gets variable for all buoys. So we get the latest observations, that's the same. We deal with our times, that's also the same. Our return is going to be different though. We don't want to just get a single station. So I'm going to use double brackets here because I want the columns of time, station, and var name. And that should be all we need for the data handling method. Now again, for the route, it's going to be very similar. A common error that I see when folks are doing this copy-paste is they will change the route name here. So instead of being single buoy, it'll be single variable. But then they won't change the name of this function, and you'll get an error that's a little bit hard to decipher. All right, so single variable, we're going to get things out of the request the same way. The data, instead of get data for buoy, we're going to use get variable for all buoys. And we are going to use var name as our user input variable. If buoy data is not none, JSON dumps, and we're actually going to have many records here, so I'm going to get rid of that 0 index. Okay, so we're going to save this, and we'll pull up our Anaconda prompt. So it hasn't crashed, at least, so there's no syntax error. And now let's go try the web service. So I'm going to refresh this to make sure it still works. It does. And now instead of single buoy, it's going to be single variable. And again, here's my autocomplete, just so we don't have to watch me type. But single variable, question mark, var name equals, and then air underscore temperature. Now I get a list of dictionaries back, and all of these have the time, the station, and the air temperature if it's available for that buoy. So really, in just about 20 minutes over the course of a couple weeks, we've made a pretty nice little API to get things from the National Data Buoy Center. There's a lot more we could do with this. We could start caching some data so that every time somebody makes a request, we're not requesting data anew from them. So we could do that locally on the server. We could get a little bit fancier with the queries that we take, or we could even take post requests. Let me know what you would like to see from future MetPy Mondays down below in the comments. Thank you for watching. I hope that you found this useful, and we'll see you on next week's MetPy Monday.